welcome Miss Ebron Gaza Jonalyn. Do I pronounce your name correctly? Miss Jonalyn, can you hear us? You turn off the microphone.
Hello, sorry for that.
Okay.
Wait, let me share my screen. Yeah, the name is properly correct.
Okay.
Thank you
All
for
right.
that. So wait, permission to share my screen. Okay, so let me just check.
Now we are seeing your first slide.
Okay. Thank you. Okay, good day, everyone. I am Jonalyn G. Ebron, a faculty member from the College of Computer and Information Science at the Malayan Colleges Laguna, Philippines. I would like to share our research entitled Design of Predictive Model in Classifying Turbidity Using Data Mining Techniques. With me are my student researcher, namely Andre Gabriel Alvarez and Miguel Mababang Loob. There were previous related studies in the literatures with the result that on the knowledge discovery databases, the KDD process starts with the initial data. Knowledge discovery databases is the process of finding useful information and patterns in data. So data mining does this by using an algorithm to extract the information and patterns derived by the KDD processes. As the result of those data may be easier for the user in both humans and computers to use. Properly transformed and validated data improves the data quality and protects application from unexpected missing data, outliers, incorrect indexing, and incompatibility in standard typing. Thus, these knowledge discovery databases automatically search the process from a volume of data to be considered knowledge, often derived in knowledge from input developed by data mining techniques. For that reason, the researchers found this very interesting and can be applied to environmental problem. In fact, in June of 2018, a new World Water Quality Portal by UNESCO, the International Hydrology Program, IHP, provides information on the freshwater quality at the global scale using remote sensing data. As water quality affects human health as well as the ecosystem, biodiversity, food production, and economic growth while improving water quality worldwide is essential to sustainable development. The portal is further addition to the set of information or tools that address the urgent need to enhance the knowledge base and better understand the impact of the climate and human-induced changes on water security, support in the implementation of the Sustainable Development Goal on water and sanitation, directly to the water quality and directly to the water pollution. The portal, which was developed in the framework of the UNESCO IHP, provides data on the 5 key indicators of the state of water quality. And one among those 5 indicator is the turbidity and sedimentation distribution data. To continue, let me define this term to help you understand more the water quality context of the study. Water quality refers to the chemical, physical, and biological characteristic of water based on the standard of usage, while sediments are naturally occurring materials that is broken down by the process of weathering and erosion and are subsequently transported by the action of water, wind, ice on the particles. So turbidity is a measurement of how cloudy the water is in the lake. It is a significant indicator of overall water quality, and it is an expression of a property wherein the light is scattered by suspension particles presented in the water and is measured in nephelometric turbidity units. So hence, the more turbid the water is, the lesser the quality of the water. Okay, in the Philippines, the Laguna Lake is the largest lake and in the Philippines, Laguna Lake is the largest lake and is one of the largest in the Southeast Asian, according to Cinco in his report in 2017 and 2018. In this report, the lake is dying. Domestic waste caused by residents surrounding the lake is the main contributor of the pollution. Also, anthropogenic activities that affect the bodies of water. The government, together with the Laguna Lake Development Authority and the partner local government units, address the importance of water quality regarding human health and become widely recognized in the recent year. One of the outcomes identified in the plan is to increase the country's potential growth by building the foundation for a globally competitive knowledge-based economy where technology adoption and stimulated innovation and envision to achieve through research. The integration, therefore, the government plan to harmonize research ensures that the integration of the research and development priority for the sector can be a sustainable community in data analytics. Analytics that can be used on environmental activities. With that, it is the rationale of doing this study. The key challenge is to provide helpful information that is essentially sustainable development. Reliance data is scarce, especially in remote areas and developing countries where monitoring networks and capacity are lacking to determine which parameters and attributes can be used as inputs in monitoring and improving water quality. The objectives with that, the study aims to provide a predictive model that utilizes the water quality data in determining the attributes and parameters used as input in designing a web-based system for classifying turbidity. The study was guided by a senior environmental management specialist from the Laguna Lake Development Authority and a city environmental officers from the local government units, including environmental engineers. Specifically, it designed a predictive model using a data mining technique that works by analyzing historical data and generating a model to predict the turbidity. The developed web-based application in the form of the dashboard that can be integrated, that presents graph, predictive model and results, and lastly, to test the model's accuracy, precision, and recall's effectiveness. I'll go to the materials and methods, and I believe that this is the highlights of the presentation today. So data were collected with approval from the LLDA in the Philippines. The collected data from the existing databases from different stations were scanned for parameters and attributes that significant factors that affect the result of classifying the turbidity. Non-significant attributes were removed for better accuracy. For data preparation, I would like to give you an overview of the three essential components for data preparation. The first one is the data source, where data can be recorded in a different formats and stored in a different storage. The second one is the data extraction, where the cleaning and the storage of data will be processed in an ETL process, extract, transform, and load to a data warehouse to store. And the study developed a framework as shown in figure 1, the conceptual framework of the study, wherein it is based on the input process output components. So as you see on the screen, the data preparation, the data extraction and cleaning was done on the input component. So when this phase has been done, a process will be conducted wherein the data will be splitted into to be used for the training and the data set, wherein for the training data set, data mining techniques were used, namely artificial neural network, the support vector machine, and the k-nearest neighbor. So you can see here that the process involved identifying the hyperparameter tuning and the future selection of classified data. So when these two was be done, the model training will now be conducted to test and validate if the three models, from the three models, which is the best fitted for the data to be used. With that, doing the testing on the model to validate it, the researcher used the picture selection correlation and the mean squared error and the accuracy computation in a program using Python library to validate all the reason. As we know, when we do processing in data mining, we have to do a trial and error. And most of the time, the researchers use most of their time doing the trial and error for the model evaluation. And the result of this framework will be the model's performance and the predicted classified turbidity. So when the model was tested and validated, the researcher now designed the data representation to a web-based system, applying the data mining techniques and the patterns identified through a knowledge that can be used by the LLDA in their data analysis. With the framework presented a while ago, the justification of doing this study is to address the gap identified in the water monitoring report of the LLDA upon the review of their methodologies in collecting. As you can see here, there are different stations and tribunalities of the Laguna Lake. So for the purpose of the research, the scope of the study only covers the 9 major stations. And these 9 major stations are collecting sample and prepare reports and analyze the water quality by their team to get the sample, and then it will be transported to the microbiological LLDA microbiological team to compute. So in a computer science perspective, computing power is a very essential tool or simply a model that can really help them to do the data analysis. So the data that were, the sample that will be collected from the major station will be collected and processed in a very long time. Not to mention that they don't have a centralized database or a system that can be integrated to the different station. So the microbiological scientist teams requires more time, at least a month for them to do the analysis. And not to mention the collection also takes a lot of time. In what you can see here, the reports will be written in an Excel sheet, although Excel is very powerful in terms of recording. However, integration and centralization of the data is very important because reports regarding water quality is very essential, and it cannot be done in a very long time. So with that, the researcher decided to present the conceptual framework on how to help these people to deal with their data analysis and recording. Okay, the data used by the study came from the LATA in the Philippines. A total of 432 unfiltered records from different time stations recovered from the year 2009 to 2016. You can see here a sample of an Excel where they have those data collected from the sample and was submitted to the LLDA microbiological team. The water quality parameters in this study are conductivity, dissolved oxygen, total coliform, total suspended solids, temperature, pH, and the turbidity. A total of 214 was used after the pre-processing, which include data cleaning and attribute selection using average techniques. Data attributes, furthermore, the data sets provided attributes that were in relation to the water quality qualification. The attributes are derived from the water quality report on the Laguna de Bay and its tributary rivers reports. Attributes supported by different literatures, as what written on the paper, are related to the prediction of the water sediments quality parameters, were parameters, stations, year, and month. The data mining techniques used in this study are the following: classification analysis, regression analysis, artificial neural network, sector vector machine, k-nearest neighbor, and predicting modeling. Confusion matrix was used in the study for the evaluation of the model as suggested by most of the related literatures related to the study. This technique shows the number of correct and incorrect predictions made by the classification model compared to the actual outcomes. The three metrics used to evaluate a classification model are the following: accuracy, precision, and recall. Accuracy is defined as the percentage of the corrected prediction for the test data by dividing the number of the correct prediction by the number of total prediction. The researchers used the scikit-team library of Python for the machine learning to run the confusion matrix. The confusion matrix if confusion matrix functions so that the calculation will be easy. In order to allow the future data to be predicted, classification analysis was conducted on the data sets that include the selected parameters. The data set for the classification was added with the new attributes, which is the turbidity. What you can see here is a figure of the correlation of the parameters with turbidity. So the 6 parameter mentioned earlier was tested using the correlated Pearson correlation, and the result shows that a predictive model was developed that classifies turbidity as good or bad using the turbidity parameters. Table 2 shows the statistical summary before and after the pre-processing of the data set. It shows that the water data, including conductivity, dissolved oxygen, pH, total coliform, total suspended solids, and temperature were on a different standard measurement. So what the researchers did is that they come up to a data standardization of all the data sets before training all the predictive model to make the values of each features in the data sets have a zero mean and a unit variance was done. Standardization of the types of measurement is helpful to compare attributes that vary in units of measurement. Here, the researchers use the basic SI system as recommended by UNESCO and World Health Report. Table 3 shows the F values of the attributes with turbidity. Using a feature selection method. Feature selection is the process of reducing the number of input variables when developing a predictive model. Here we show the approach on how we selected the input parameters that can be used as input. Table 4 shows the distribution of the binary classifier in the data sets that the researcher used to determine what is good and what is bad, level of turbidity value. In this study, we use the standard ranges of the NTU value. If greater than or equal to 25, that is good. And if the NTU is less than or equal to 25, that means it has a bad turbidity. The meaning of this example from the different station, before that, the NTU value used for the classification of the turbidity is based on the Oklahoma standard of water quality and also was suggested in most of the related studies. So what does it mean? So from the table, it shows that only station 1 has the value of 23, and that means that the classifier identify this value from the data sets. As the results of the performance of the model accuracy, Table 7 shows the performance of the 3 attributes combination model using the ANN, SBM, and KNN per station. In the study, the researchers did different types of model testing from 6 attributes, 3 attributes down to 1 attributes to test the model combination in selecting the most significant values of the parameters. The 3 machine learning techniques frequencies based on the table as what we have seen here were not that far. After comparing the performance of each model, KNN models produce an accuracy of 1, which is in bold. So the result shows that KNN is not equal to 1, but it shows here that the ANN is not equal to 1. However, it has a significant high value of 0.88.
So sorry for interruption, Ibern.
Okay, so the results of the
three minutes for presentation.
Okay, so the results of the MSE confirmed that the accuracy is 1 and the MSE is 0. The higher the accuracy, the lower the MSE. It indicates that the more accurate the model is, the less error it produces. The data mining techniques with the 3 attributes combination are best to use in a specific station. An accuracy of 1 is the highest, and which is the station 5 and 8, and 0.7 lowest accuracy, which is in station 8. So this is the output of the web-based application as what you have seen on the screen. So the model that was validated and tested are now implemented in the model. So the web application give an administration account to the user of the system, an admin account wherein they can do all the importing of the data from the different station and the user page. So this is the visualization of the web application that we developed after implementing the model. Furthermore, this visualization of graphs and tables further helps to recognize emerging trends in response to the rapid grounds of what we can see on the graph. Such patterns that make more sense on a graphical representation because visual makes it easier to identify strongly correlated parameters. So conclusions and recommendation in this paper, a predictive model that classifies the turbidity of the water was developed, and the attributes can be used as input in providing helpful information to protect water and avoid water pollution in better decision making. The web application developed would be a helpful tool for data accessibility and availability of the result of the model to aid the LLDA to come up with a more reliable model for future planning. It addresses the difficulty of comparing data sets from different stations caused by distinct selection and analytical processes. It is suggested to make the model more dynamic to continue analyzing big data as it fed through, making the model's data result more reliable and accurate. So I would like to acknowledge Malayan Colleges Laguna, the Laguna Lake Water Authority, the local government units in assisting us to come up with this project. So with that, safe water protects and save lives. Thank you.
Thank you, Janalyn. So I think we over time now, so we have a very quick questions.
Okay.
Anyone has questions? Please, the audience. If not, I have small questions.
Okay.
Could you go to page number 16? I think in your slide, page number 16. I can't remember it correctly. It's about the standard deviation. So what I observe is, I think the standard deviation is very large. Not this slide. Continue on. Next one, please. Another one. Yeah, this one. So the mean, for example, the conductivity, that attribute, the mean is 463, but the standard deviation is over half of means and variance is so large. Could you explain anything about them? I think this number is quite, sorry to say like that, is quite strange. Yes, the standard deviation is very big.
Table number 2. Am I right? Table number 2.
Yeah, and also the total polyform is so large. Do you think this data is useful to calculate, or is that reliable?
Actually, during the pre-processing of the data set, we encountered some problems with regards to the standard deviation. So what you can see here, as mentioned, that the standard deviation is very high and most of the data was totally scattered from the mean, no? If we are going to interpret that. So it indicates the value were far away for each other. However, the parameters was assigned a constant value on the training the model to overcome the overfitting later. And the averaging techniques helps a lot in treating this data. So this table represent only the methods of how we do the pre-processing before training the data sets. So, and that is already been observed. That's why we come up to a technique or an algorithm to address later the higher value of that deviation. And as what I explained in the model accuracy, when we do the performance testing, so using the constant value assigning of 0 to those data variables and the averaging technique and the data mining technique used, so we come up to a correlation of the result of the accuracy using the MSE and the confusion matrix to lower the errors.
Okay, thank you. So if you have any questions, please feel free to ask. Yeah? Okay, I think we come to the end of this session. So I would like to take this opportunity to thank you, all of the artists, the presenters, I mean, and also RC conference teams. Dr. Rong, do you have any questions? Dr. Rong is from computer engineering. Please go ahead. Sorry, please go ahead.
A question. The accuracy, maybe some station is high and maybe some station is low. it is because of the features, not because of the classifier. Do you think that the features such as pH, temperatures, or can be used to represent the turbidity enough? And maybe it's about, there are several issues that may be discussed. For example, if the temperatures of the air is higher, maybe just about 5 degrees Celsius, okay? You use a temperature as a features, and when the temperature is higher, just your standard deviation is just about 2 or 3 degrees in Celsius, okay? The question is about the features that do you think is enough that can be used to represent the turbidities, something that apart from the classifiers?
Well, sir, actually, when we studied the data sets coming from the LADA, when we started the project, there are many parameters that can be used on water quality. However, the study is limited to the 6 parameters, including turbidity, because in the Philippines, they used the 6 parameters, but not including the turbidity. So that's why, based on the related literatures, after reviewing the previous studies, they are recommending that turbidity, other parameters should be used to test if there is a possibility of high correlation with regard to the turbidity level. However, the data that we get were actually processed already by the microbiological teams, and the data are already computed. So our role is to analyze those data and do the model somehow to test the correlation of each parameters, including the turbidity. And the result of the study come out that with the 6 parameters mentioned earlier, with regarding to turbidity, only 3 among the 6 are highly correlated. So that's why the values associated with the deviation of the highest and the lowest was done during the pre-processing. And because, as we know, data treatment is very, because when the data is not clean enough and we cannot come up to a very good data sets to be inputted on the system, on the analysis of the classification, either bad or good, so it will never give us a good result in identifying the model.
According to the data, maybe, for example, the temperature is higher than 10 degrees. Okay, maybe it can affect the feature easily. Even in your field, maybe it's because of the bacteria in the water, and yeah. I'm not sure. But the sunlight during the noon maybe has more effect than the bacteria in the water. And in some feature, for example, it seems that the length of the standard deviation of the pH is quite low, and it may be and it may be difficult for now to use some features to distinguish the quality of the waters, and maybe just
that's very interesting to acknowledge. Actually, based on our research, there are still more parameters to be studied. Actually, this is the first research that conducted to analyze those data, and as a starting point to come up with a baseline, I think the model that we develop can also be used on a different classifier or attribute later in the future once we already come up with this model. So feature selections of attributes is very essential. And with regards to data, in water environment, as we know that there are many microbiological behaviors and characteristics. So maybe we can work with those scientists in their domain, but in computational science, as part of our role in the computing industry, so what we can do is to provide a model
Thank
as a
you.
tool
Thank you
for
very
them.
much.
Thank you.
Okay. So if you have the further discussions, maybe you can exchange your email and contact later. Thank you, Dr. Rong. So I would like to hand to Kun Thanet for the end of the session. So before that, by the way, I would like to give a big applause for every presenter to for helping run these sessions smoothly, successfully. So thank you very much.
Thank you very much, Dr. Prapon Chawaportiv. Okay, thank you everyone for coming to the RSU conference in 2022. See you on next time. Have a time. Okay.
Thank you, MC.
Thank you very much.
Do we have to take a photo? A screenshot?
Okay. The last time
Shall we?
take the photo.
Okay, so please, everyone, please, yes, thank you. Turn on your camera. You should
Please
have a one
open the
screenshot.
camera.
Who's going to snapshot?
Bon. Hello. Bon.
โทษทีครับอาจารย์เดี๋ยวผมหาแคปก่อนครับ
Okay.
Oh, okay. So, Kun Thanet will be the one who.
เจอแล้วครับ
Okay, you will say 1 through 3, okay, so that we can know when to smile.
1, 2, 3 capture
ให้คนแคปเจอร์คนเดียว
Okay, thank you.
Okay, thank you very much.
Thank you very much.
Thank you very much for joining us.
See you next year.
ครับ
ได้ไหม
สวัสดีครับอาจารย์โรงสวัสดีครับ